in fault 3. Okay? Now, we already know how to turn this unit on. Okay? Make sure the gas is turned on. This is the power switch. This is actually the switch on the side of the furnace. Okay? Call for heat. The gas on. Okay? And the unit lights. Okay? Okay, now it says here, turn on the gas shutoff valve, provide spark to the trainer. We did that, okay? Set the system, or plug in the cord, so on and so forth. I'm just going to jump down here by the bolts here. The 3 switches in the back of the trainer will simulate 3 common faults of the spark ignition module. With your voltmeter, determine each fault at the gas valve, PV, MV terminals, and at the module 24-volt terminals. Keep in mind, this is a trainer. Typically, you will need to check for faults at the module terminals. Okay? Now, step 2, first fault. Place the first switch in the down position. Okay, so right now I have all 3 switches up in the upright position. Okay? So if you guys want, take a look at behind here. Okay? These are the 3 switches right here. Okay? 1, 2, and 3. Okay? Another thing we've got back here is this device here. Does anybody know what that is? That's a transformer. That is a step-down transformer from 120 to 24 volts. Okay? Keep in mind, that is in part of the equation here. Okay? Here's our transformer right here. 120 volts coming in, 24 volts coming out. Okay? All right. Okay, so now let's go to the front of the unit. All right? Okay, now, when all the switches are in the upright position, it runs normally. Okay, so check it out. Okay, our power is turned on, our gas is on, our gas valve is on. Number one thing that people forget to do with this is that they forget to turn the gas valve on. Okay, off, on. Okay? Alright, now, this is the gas for the spark igniter. This here is actually made this. This is actually our burner. So this would be like the in-shot burners, but we just have like a little Bunsen burner, as you would see in the science lab. Okay? So what happens is, we call for heat, okay? Spark, pilot, burner. Normal operating conditions. Okay? This is the mercury flame sensor. We don't even, just ignore this. We're not even using this anymore. Not even in the equation. We only had this here for that one lab that we did a couple weeks ago. Okay? So ignore this. Not part of it. Alright? So now, we have our burner and it's running perfectly. Okay? Now, it says here, okay, place the first switch in the down position. So what I'm going to do is I'm going to take the first switch number 1, put it in the down position because the thing told me, or because the paper told me to. Set the system to call for heat at the thermostat. Okay? Determine what fault is in Determine what fault is in the system by checking the voltage at the gas valve, PV, MV terminals, and the module 24 volts. What did you determine to be fault number 1, and then justify your answer? Okay, so switch 1 is in the down right position. So let's call for heat.
Nothing.
Nothing. Okay? Check it out. I'm going to put switch 1 upward. Okay? Alright, let's do switch 2. We're going to go back to this. I'm just showing you what the faults are. Switch 1 and 3 are up. Switch 2 is down. Now watch the sequence of operation. Okay, our pilot lit.
But not the Bunsen burner.
What's that?
Not this one, right?
Yeah, what is that?
The burner. Bunsen burner.
Okay, so our burner's not on. Okay. Now it's on. Here's switch 3.
So 1 and 2 are down.
Oh, is that just this?
1 and 2 are up.
Up.
3 is down now.
3 is down.
So they all got to be off in order to work, right?
All exactly.
Also, is that like?
So I'm just showing you the faults.
Okay.
This is switch number 3. Okay. Now they're all up. Now it's working.
Is the third one the spark, which makes it light or something like that? The spark PV?
No.
No.
Okay, here, let's do it. Let's start over, okay? All right, switch 1 is down. Let's figure out what's happening here. Call it for heat. Nothing's happening.
No spark?
Nothing.
We need to figure out what's happening. Okay, we're calling for heat and nothing's going on. Okay? So, let's take a look. Now, on our gas valve here, we scored some of the insulation back off of these connectors here, okay? On the control module and the gas valve. On the gas valve, these wires, okay, from MV, MVPV, PV, all go down to the back side of the trainer, come through the bottom, and plug into the gas valve. Remember what I said in class, guys. MV runs all the way down and is connected to MV on the gas valve. Somebody wrote right down here, MV is on the bottom side of the gas valve. MVPV is in the middle. And then PV is on the top, okay? So, we need to figure out why nothing is happening. Switch 1 is down, okay? So let's take a look, all right? So what I'm gonna do is, first thing I'm gonna do is I'm gonna go from MV, or MVPV to PV. The reason why I'm going to PV, because that's the pilot valve. We need a pilot first to light our burner, right? All right, let's check it out. Let's see if we've got voltage at our gas valve, okay? So, I said MVPV is at the middle, and then pilot valve is on the top. So let's set this to volts, okay? All right, I've got no voltage at the gas valve. I need to work my way backwards, okay? So, we're gonna follow the wires up. So let's see if we got voltage up here at the control module. MVPV. What do I got there, Andrew? What's that meter saying?
It says
0. Point what?
0.19.
That's nothing, right? That means there's nothing there, okay? Okay, so the power is being fed into the control module. Goes this way, goes down to power up our gas valve. Let's see if we got our voltage coming into our control module. So we're working our way backwards as we're doing troubleshooting, okay? What do I got again? Yep. So what's wrong, guys?
So 1 is the supply.
What's that?
That's the power supply.
What?
The switch 1.
So it's gonna come from the back.
What did you say?
Transformer.
Did you hear that, guys? Look what it says. He's right.
It's 24 volts.
We're not getting 24 volts.
Yeah.
That's okay. Thank you. We're not getting 24 volts to our control module. We need to have 24 volts supplied to our control module to open up our pilot valve. Okay. Keep in mind the MVPV is common to PV. MVPV is also common to main valve. Once our pilot lights, it lights the pilot, and then once the pilot is lit, then it's going to light our main valve. So if we've got no power coming in because he said the transformer's bad, and he's right because I put my meter there, let's check it out. Let's verify it again. I've got no power coming in. So I've got no 24 volts being controlled to it.
So number 1 controls transformer.
So we have a bad transformer because it's not supplying control voltage to our module. Yeah, it's on. It's
So
on.
that's the fault 1.
Okay? So, it says here, what did you determine the fault number 1 to be? Like he said, bad transformer.
Bad transformer.
Why is it a bad transformer? Justified? Why is it a bad transformer? Because we have no 24 volts being supplied to our control module. Okay? Now, we pretty much did the first one together. Okay? Normal. So all the switches will be in the upright position. Okay, here we go. Pilot, burner, bam. Check it out. Now he said we had no voltage. Now let's take a look. What's our voltage down there now?
25.
25.
25 volts. So we're good. We have over 24 volts. Okay? Very nice. Let's take a look at the MVPV. How many volts are we reading? 25, right?
25.
Let's look at our main valve PV. 25 volts. And it's right because we have a little bit of voltage being supplied to our pilot valve, and we also have the voltage being supplied to energize the coil to open up our main valve. Keep in mind, guys, we got to supply 24 volts to our gas valve to energize the coil inside to open up and allow the gas to flow. Once we take the voltage away, the power goes away and the valve closes just like that. Because this is a normally closed valve, okay? Once you take the power away or it fails or the coil burns out that opens the valve, it kills itself, it dies, okay? And it's supposed to. We give it 24 volts, it opens up. It lights the pilot, then it lights the burner, and we're good to go. Okay? Keep in mind, guys, you can also check your voltages down here, okay? At the gas valve. But I gotta warn you, okay? Don't burn yourself. I mean, you might be doing one of these and
So it's better.
okay? No, you may have to check down there too,
okay.
but just keep in mind, okay?
Yeah.
Watch your hair, okay?
Yeah.
Just letting you know. Okay? All right, now, real quick. Okay, that was switch 1. Let's review it again, okay? Now this is switch 2. Got our pilot.
But not the burner.
What's that?
Not the second one. The burner.
Not the burner, exactly.
We're
Okay?
waiting for 2.5 minutes to the burner to start now.
Our burner's not coming on. So I'm going to tell you what's wrong, okay? I'm just going to tell you from experience, okay? We're not allowing 24 volts to the gas valve. Or if we are allowing 24 volts to the gas valve should be open, right?
Mm-hmm.
So if we read 24 volts at our gas valve at the main valve MVPV, because MV and MVPV should have 24 volts to call for our burner. If we have 24 volts to this, it's not opening. What's wrong? The gas valve is bad. We're giving it the power, but it's not opening. Right? Okay. Very good.
What if it was giving it, but this wouldn't light up?
Then our gas valve is bad. Because what's happening is that the valve is probably bad inside or it's not opening. If we got 24 volts, I don't want to burn myself. We got 24 volts there, allowing the gas to flow, but it's not doing anything, the gas valve's bad. Okay? Okay. Now they're all on. Okay? Here's switch 3. Again. We're trying to light. What's happening?
It's getting volts.
It's getting voltage to create a spark because we're getting our voltage to travel through here to create our spark.
Yeah.
Pilot.
Pilot valve.
Pilot.
He's right. So the pilot's not opening. So if we're getting 24 volts to our PV, MV, and MVPV, so if we're reading 24 volts to our pilot down there, what's happening now? And it's not allowing gas to flow. What's happening?
Yeah, the pilot is not receiving the power.
Oh, there's a
No,
power. There's a power.
What's that?
The gas valve itself.
He's right.
Because
Gas
there's a power here. Yeah. The solenoid is it's not
Yeah.
working.
You guys are right. Okay, so what's happening is, okay, we're supplying our 24 volts to our pilot valve now. Now the pilot valve's not opening. So what that means is that if we have power at our PV, MV, which is down here, okay, we're reading 24 volts to open up our pilot valve of the gas valve, and it's not doing anything when we have voltage there, then our gas valve is bad again also, because now the pilot valve is not open.
When we're like testing them and
MV, MVPV, and PV are also down here. Okay, it's written on the back side of this here. Okay, and then somebody also wrote it in pencil right here. So on top is MV. The middle one is always MVPV, and then PV. Okay, remember what I taught you guys last week with this? Number 4 was common.
Yeah.
Okay?
Uh-huh.
And then also on the CDP switch, yellow was common.
Yeah.
On this one here,
MV.
MVPV is common. And it actually tells you. So it tells you that PV and MVPV are common. Or I should say, let's just say PV and PV here are common together. And then MV and MV here, those are common together also. So your center one is common to the MV, and it's also common to your PV. Same thing down here. If you notice, it's in the middle here. It's also in the middle on the gas valve. So I pretty much told you what the answers are. Now you just have to witness it and see it and check for voltage. The pilot valve to allow the burners to light. Any questions? That's technically a meter. So let's take a look. It should read 24 volts. And it does. 25 volts actually. It's reading, okay, we're supplying 25 volts to our main valve, and we are, because we know, because it's open, it's on. And the pilot, because we see the pilot is on.
Yeah.
Okay. Same thing down here. 25 volts. 25 volts. Okay. Common, it should reads nothing. Yeah.
That's a one.
Okay. That's the neutral, or the common, I should say. This is common. This is common to here, and this is also common to the pilot valve. It tells you right there. Okay? So let's take a look at something. See? We're getting 25 volts to the pilot valve. Down here. Well, technically, this is supposed to be supplying the voltage down there.
That's a one, no?
Yeah. Okay? See, we're getting voltage to the pilot valve, but we're not getting voltage to the main valve. Why we're not getting voltage to the main valve? Because the pilot valve didn't light yet. We need to have the pilot on first before we get power to the main valve. Once we do that, then we're going to have power to our main valve. And we do. Okay? If you want to use this, you can.